section 2.5 basis for C and CPUB. Already know C and CPUB. Okay. So here S be the non-empty subset of Km. The first two algorithm provide a basis for C is equal to a space generated by S, the linear chord generated by S. So first algorithm 2.5.1, we have 4 algorithm. 4 എണ്ണം നമ്മളോട് കൺസിഡർ ചെയ്യുന്നുണ്ട്. Okay, 4 അല്ല, I think. Wait. So first algorithm is form the matrix A whose rows are the words in S. Use elementary row operations to find REF, that is reduced echelon form of A. Then the non-zero rows of the REF form a basis for C is equal to space generated by S. Okay, so നമുക്ക് മെട്രിക്സ് നമ്മൾക്ക് എ പറയുന്ന മെട്രിക്സ് നമ്മൾ ചെയ്യുന്നു. ദെൻ റെഡ്യൂസ് ടു എ റോ എക്ലോൺ ഫോം. റോ എക്ലോൺ ഫോമിലേക്ക് നമ്മൾ റെഡ്യൂസ് ചെയ്യുന്നു. ദെൻ നോൺ സീറോ റോസ് ഓഫ് ദ റെഡ്യൂസ്ഡ് എക്ലോൺ ഫോം എ ബേസിസ് ഫോർ സി. ക്ലിയർ? അപ്പോൾ ഒരു സി എന്ന് പറഞ്ഞ കോഡ് വേർഡിന്റെ ബേസിസ് കണ്ടുപിടിക്കാൻ പറഞ്ഞാൽ ഫസ്റ്റ് എന്ത് ചെയ്യുക, തന്നിരിക്കുന്ന മെട്രിക്സിന് മെട്രിക്കിലേക്ക് കൺവേർട്ട് ചെയ്യാം. ദെൻ ഇറ്റ് ഈസ് റെഡ്യൂസ്ഡ് ഫോമിലേക്ക് കൺവേർട്ട് ചെയ്തിട്ട് നോൺ സീറോ റോസ് എലമെന്റ്സ് കൺസിഡർ ചെയ്യാം. സോ ദാറ്റ് ഈസ് ദ ബേസിസ് ഫോർ ദ സെറ്റ്, basis for the code C. Okay, so algorithm works because rows of A generate C and elementary row operators simply interchange words or replace one word with another in C, giving a new set of code word which still generate C. Clearly the non-zero rows of the matrix in REF are linearly independent. So non-zero rows of the REF form a basis means what? They are linearly independent. So that is the linearly independence. So question വരുമ്പോൾ find the linearly independent set എന്നൊക്കെ question ചോദിച്ചാൽ, so first എന്ത് ചെയ്യുക, A പറഞ്ഞ മെട്രിക്സിനെ റെഡ്യൂസ്ഡ് ഫോം ആക്കുക, converted into a reduced echelon form. Then a non-zero rows of the elements which form a linearly independent set. For the set is C, for the chord C. Okay, so here for example, so question is find a basis for the linear chord C or find the linearly independent set for the linear chord C. As any question ചോദിക്കും. So first so the set is S 1 1 1 0 1 0 1 1 0 0 1 0 1 1 1 1 0 1 1 0. So this set into a first നമ്മൾ convert into a matrix form. Then reduced form and the so first entry is leading one. So first one is leading one and a column contain 1 and 1. So convert to a 0. So first adding 1 and 2. So we get 1 plus 1 is 0. 1 plus 0 is 0, 1. 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 0 is 1. So second entry is this one. Third entry is 0. So there is no change. And fourth row is 1 plus 1 is 0. 1 plus 1 is 0. 1 plus 0 is 1. 0 plus 1 is 0. 1 plus 0 is 1. Okay. So we get this one. Second entry is 1. But the column contain other one. So convert into a 0. 0 0. Okay. And so here നമ്മളോട് ചെയ്തിരിക്കുന്ന 0 അക്കല്ല, 1. Here നമ്മൾ ചേഞ്ചിങ് ചെയ്തിരിക്കുകയാണ് കേട്ടോ. I'm sorry, this convert into this matrix and column 2 and column 3 just interchange. This one is just interchange ചെയ്യാണ് column wait. Okay, So we get first one, this one. So leading 1 and other entries is 0 ka. So we get this one. Okay. The next നമ്മൾ ചെയ്തിരിക്കുന്നത് വെച്ചാൽ third column, third rowയും fourth rowയും just interchanging. So interchanging the row, third row and fourth row. So we get 1 1 1 0 1 0 1 0 1 1 0. This one become to R4 become R3. So 0 0 1 1 1 0 1 0 1 1. So adding this two rows, row 2 and row 4. So we get 0 plus 0, 1 plus 1 0, 0 plus 0, 1 plus 1 is 0, 1 plus 1 is 0. So we get this one. 1 1 1 0 1 0 1 0 1 1 0 0 1 1 1. Okay. And next adding second row ne interchange cheyyam. Okay, so adding row 2 and row 3. So 1 1 1 0 1. Second row becomes 0 plus 0 0. 1 plus 1 is 1. 0 plus 1 is 1. Okay, 1 plus 1 is 0. 1 plus 1 is 0. Third row is 0 0 1 1 1 and fourth one is 0 0 0 0. So we get this one. Okay. So a non-zero rows. Non-zero rows is what? First one is 1 1 1 0 1. Second one is 0 1 1 0 0. Third is 0 0 1 1 1. So this non-zero set form a the non-zero element is this 3 rows. So these 3 rows form a basis for C is equal to space generated by S. Okay. So this is the basis or linearly independent set. Okay. So ഇതാണ് ഇവിടെ converting. But just interchanging rows and column. Interchanging rows and row. Similarly, interchanging columns and adding 2 rows and similarly adding 2 columns. അപ്പോൾ ഇത് എങ്ങനെ നമ്മൾ യൂഷ്വലി നമ്മൾ റെഡ്യൂസ്ഡ് ഫോം ചെയ്യുന്ന അതേ സെയിം കാര്യങ്ങൾ സെയിം വേ തന്നെയാണ്. So we can find the basis or linearly independent set also. Okay. So this is the first algorithm and this is the basis for C. Linear card C. Okay. So next algorithm said ഇവിടെ നമ്മൾ non-zero rows consider ചെയ്യില്ലേ. Similarly, non-zero column also form a basis for C is equal to basis for a linear chord C. Okay, so this is the second algorithm set. So here the example. This example. But we original matrix constraint. From the matrix A whose columns are rewards in S, use the elementary row operations to place A in REF and locate the leading columns in REF. Then the original column of A corresponding to this leading column form a basis for C is equal to S. So first algorithm said and the non-zero reduced in REF, a non-zero rows form a basis. Here, example. First, consider this example. So A is the matrix. This reduced to form a this one and this one. Okay, here a non-zero column say the kya. So first row. Wait. First, so here leading one nalla parayunnathu leading columns aanu. So here consider, so this is the REF. So this first column. So first column, first element is leading element. Okay. And second column, consider the second column. The first element is leading one. Okay. But third column എന്താ first entry എന്താണ് 0 and fourth column is first entry is 1. So here 1, 2 and 4. These are the leading one. So leading one പറയുന്ന first entry എന്തായിരിക്കണം? First entry must be 1 ആയിരിക്കണം. So that is the leading column. Okay. So here 1, 2 and 4 are the leading column. So corresponding to the original matrix 1 and 2 and 4. So these are the one is 1, 1, 1, 0, 1. That is this one. And the second one is 1, 0, 1, 1, 0. And the fourth one is 1, 1, 0, 1, 0. So these three elements form a basis for the linear chord C. So രണ്ടിനെയും algorithm one. First algorithm is in REF a non-zero rows form a matrix. Second algorithm is in REF, that is in reduced echelon form, a leading column. Leading column is the first entry must be 1. So that columns will corresponding to the here 1, 2 are and 4 are the leading columns. In the original corresponding to the original matrix 1, 2 and 4 are the basis elements. Okay. So that is the 2 algorithm. In the next algorithm ഒക്കെയാണ് നമ്മൾ ഇവിടെ റിസൾട്ട് പഠിക്കുന്നത്. This one. Form a matrix A whose rows are the words in S. Use elementary row operations to place A in RREF. That is reduced. What is REF? Reduced row echelon form. Okay. Let G be the K by N matrix consisting of all the non-zero rows of the RREF. നമ്മൾ മെട്രിക്സിനെ റെഡ്യൂസ് ചെയ്തിട്ട് RREFലേക്ക് നമ്മൾ കൊണ്ടുവരുന്നു. സോ അവിടുത്തെ non-zero entries. Okay. K by N matrix consisting of all non-zero entries. So that is the matrix G. And the next X. X be the K by N minus K matrix obtained from G by deleting the leading column of G. So leading column of G ne delete ചെയ്തിട്ടുള്ളതാണ് X. So X is the matrix K by N minus K. Form an N by N minus K matrix H as follows. So നമ്മൾ ഇവിടെ H follow ചെയ്യണം. H എന്ന് പറയുന്ന matrixനെ consider ചെയ്യണം. So in the rows of H corresponding to the leading column of G, place in order to the row of X. Second one is in the remaining N minus K rows of H, place in order the rows of the N minus K by N minus K identity matrix. So H എന്ന് പറയുന്ന matrix എന്തായിരിക്കും? Matrix X with I ആണ്. Okay. So this one. H dash നമ്മൾ notation കൊടുക്കുന്നേ ഉള്ളൂ. But ഇതാണ് matrix. X with the matrix I ആണ്. So that is the H. Then the column of H. Then the column of H form a basis for C per. So usually നമ്മൾ എന്ത് പറഞ്ഞു? First നമ്മൾ എന്താ? We find the basis for C ആണ്. So here we can find the basis for C per. So first നമ്മൾ എന്ത് ചെയ്യുന്നു? G എന്ന് പറയുന്ന matrix construct G with the K by N matrix consisting of all non-zero rows in RREF. Okay. And next X. X be the matrix K by N minus K deleting the leading column of G. Then form an N by N minus K matrix H. H is X with the identity matrix. Okay. So that is the column of H form a basis for C per. So we first we find the matrix H, then each column which forms a basis for C per. The algorithm works because n minus K column of H are linearly independent. Dimension C per is n minus dimension C, which is equal to n minus K. And totally നമുക്ക് എന്താ പറയാം? Dimension of C plus dimension of C per, which is equal to n by the Hebel theorem. Okay, so this is the description, and so this is the description and here the problem. So here A be the matrix which reduced to a RREF, reduced echelon form, this one. 1 0 0 1 0 1 0 1 1 0 0 1 1 1 0 0 0. Okay. So number of non-zero elements. Number of non-zero rows. So here 1, 2, 3. These are the non-zero rows. So that is the matrix G. Okay. So this is the matrix. And here K is equal to 3 തന്നിട്ടുണ്ട്. And X is equal to, what is X? X is what? It's a K by N minus K. That is 3 by N minus. N is 1, 2, 3, 4, 5. That is 5 minus 3. That is 3 by 2 matrix. So here the 3 by 2 matrix. 3 rows and 2 columns. Okay. So X is what? 0, 1, 1. Deleting and then deleting the leading columns. Deleting the leading column is, this is the first element. What is leading column? Each column contain exactly one element. So here the first column is containing exactly one element, and second one is containing 1, and third one is 1 1. So deleting X is what? Deleting the leading column of G, that is the matrix X. So 0 1 1 1 1 1. This is the matrix X. Okay. What is H? X with the identity element. X is K by N minus K. That is 3 by 2 matrix. So X is the 3 by 2 matrix. Here identity is 2 by 2 matrix. 2 by 2 is N by N, N minus K. So that is 5 by 5 minus 3. That is 5 by 2. So X with the identity element. N minus K nalla parayanathu. N minus K parnenda. N minus K, that is 5 minus 3, which is equal to I2. So identity element is the 2 by 2 matrix. That is X with X is what? 0 1 1 1 1 1, and with the identity is 1 0 0 1. So this is the element of H. So element of H, this is the matrix H. And what is the column of H? Form a basis. What is the column? First column is what? 0 1 1 0 1 0, and second column is 1 1 1 0 1. So these two columns form a basis for C-perp. So this is construction. So first we reduced form, then non-zero rows consider, then deleting the leading column. Leading column is, each column is contain exactly one element. Okay. So I delete the remaining part ആണ് X എന്ന് പറയുന്നത്. X with the identity ആണ് a matrix H, and each column of H form a basis for C-perp. So this is the method for finding the basis for C-perp. So usually question varum C and C-perp. Okay. So here the example, n is equal to 10 ആണ്. Already G തന്നിട്ടുണ്ട്. Leading elements omit ചെയ്യുന്നു. So we can find the X, then X with identities. Okay. And each column is form a basis for C-perp. So this is the example.